Hey everyone, in this session we will not understand any new machine learning model but an effective way to use the data samples in order to assess the performance of the model. We will learn about KFold Cross Validation, which is an important topic for all the machine learning engineers and data scientists. KFold is a technique to use observations or the data samples effectively and assess the performance of the model. There are different approaches to use data samples for training and testing the model. Let's learn each of them and understand what are the pros and cons of each approaches. Let's start with no split. In this approach, we take the entire data samples or the observations as training data of our machine learning model, and we use the whole data set during our model training step. But this is not a very effective approach to use data samples because the trained model will suffer from overfitting. Though the model performs well for training data but performs poorly for the new and unseen data. Hence, the model accuracy may not reflect the ability to handle new data in this approach. Hence, though it is a very naive approach, but in real life, we do not use this approach in any of our machine learning projects. What to do then? We will use train, test, split method of SKLearn library in order to split the entire data samples into two parts, training data and test data. We do not expose the test data during the training of the model. We only use the training data set in order to train the model. Once we get the well-trained model, we use test data to check the accuracy of the model. This avoids the overfitting in the model. Model accuracy here reflects its ability to handle new unseen data. Let's understand how train test split method works internally using this picture. The entire data samples has few of the columns which are independent columns or the features. There will be one or more columns known as target column or dependent columns. Remember, we want to predict the dependent columns with the help of the feature column. That is how it works on machine learning. Now, with the help of train test split, we can split the entire data samples into training data and test data. In training data, we have X-train and Y-train. X-train has the data frame of all the features. Y-train has the dependent column. During our training step, we use X-train and Y-train to train the model. In our previous sessions, we have already experienced how we can use train test split to split the data into training data and test data. We pass X-train and Y-train in the model.fit method of SKLearn in order to train the model. Once that is done, we can use X test and Y test to evaluate the performance or the accuracy of the model. We have a score method in SKLearn library which takes X test and Y test as its input and provides us the accuracy value, which will be 1 or less than 1. However, note here, if we execute the same statements multiple times, each and every time, train test split will give us a different set of training data and test data. And because of that, the model accuracy varies. In the first iteration, if the model accuracy, for example, is 97%, in subsequent run of the same statement may give us the model accuracy as 89%, because train test split method randomly splits the entire data samples into training data and test data. That means if we want to know the actual effective accuracy of the model, we have to execute same statements a number of times and evaluate the scores and take the average out of it. Then only we can say that this average score is the one which is a good metric to identify the performance of the model. Let's run third approach now. The third approach is KFold. KFold is more robust than train test split method, especially when the size of the dataset is small. In KFold, it folds the entire dataset into multiple folds, and in each iteration, it keeps one fold reserved for test and uses the remaining folds as training data. You can see it in this picture. In the very first iteration, we are taking the blue fold as the test data and pink folds are as training data. We perform the model training. We use fold 1 to evaluate the performance of the model. Then it will go to the next iteration. This time it will use fold 2 as test sample and uses fold 1, 3, 4 and 5 as training data. It trains the model, evaluates the accuracy of the model with the help of fold 2 dataset. In this way, it will perform 5 iterations to get 5 different scores from the same model and then takes the average accuracy as the effective performance of the model. It helps to reduce the variance in the performance estimate because we are performing 5 iterations, we are getting 5 different scores, taking the mean value or the average value as the performance of the model. So the variance or the change in performance will be minimum here. It provides more stable performance since it takes average of multiple iterations. The same thing is written what we have discussed just now. How can we use KFold? We can import KFold from sklearn.model_selection. Using KFold constructor, we can create the KFold object. Remember, KFold constructor takes an argument called n_split, which takes the number of folds we want to perform on top of the entire dataset. Here 5 means the entire dataset will be splitted into 5 folds. Once we get the KFold, we need to manually write the Python code to iterate 5 times and evaluate the accuracy and finally evaluate the mean value in order to get the effective score of the model. This will give you a more stable accuracy of the model because unlike test train split method, we are performing multiple iterations here and taking the mean value to get more stable effective score. Now, in order to use KFold directly in our machine learning code, we need to write a lot of code to perform these iterations with the help of either for loop or while loop in Python. It would have been nice if we have a single method where we will pass the n_split and the method itself automatically iterates 5 times, evaluate accuracies and finally evaluate the mean value of all 5 accuracies and provides us the effective score. Exactly the same thing can be performed with the help of something called cross val score. Cross val score is a function in SKLearn library used for cross validated performance evaluation for a machine learning model. It works on top of KFold only. This function basically automates the process of splitting the dataset into multiple folds, train and test the model on each fold on each iteration and then evaluates finally the performance of the model. All steps are automated within cross val score method. So unlike KFold, we don't have to write Python code to loop through the steps or to iterate through the steps. How can we use cross val score? We can import it from SKLearn library. Model_selection is the family where cross val score has been defined. In cross val score, we pass model independent variables, dependent variables and something called CV as arguments. We can pass different model here. For example, logistic regression or support vector classifier. Independent variables are nothing but the data frame of features. Dependent variables are the target variable column of your dataset. CV is the parameter where we specify the number of folds we want to generate. Now, if we are passing CV equal to 5, the whole dataset will be of 5 fold and 5 iterations will be performed to evaluate 5 different scores of this model and will be stored within this scores variable. If we pass 10, then the entire data set will be splitted or folded into 10 folds and 10 iterations will be needed to get 10 different scores of the same model. Each and every iteration, the training data set and test data set will be different. At a time, one fold will be taken as test data set and rest of all the folds will be taken as training data set to train the model. In this way, there will be 5 or 10 different iterations, and finally we are using scores.mean to get the effective score of the machine learning model. Hope you have realized how cross-val score is giving us ease to use KFold technique. Without wasting time, let's jump to the Jupyter notebook and write some code to explore KFold and cross validation score. We are in our Jupyter notebook to explore KFold cross validation. In these import statements, basically we are importing pandas to use it to access the data set. Support vector classifier model will be using as the model, and we are loading digits dataset from SKLearn dataset. We have used the same digits dataset in order to perform image classification with the help of support vector classifier in our previous session. Let's load the digits dataset. Digits dataset has data or the independent variables or the features here within this data folder, and the dependent variable or the target variable will be stored within target folder. We are creating the features data frame from digits.data and dependent variable or the target column with the help of digits_target. Digits_target has the actual digit value. Digits.data has the pixel values for each images. Let's first validate the approach 1, where we will pass the entire data set as the training data without splitting it into training data and test data. Let's see what score we get. The score is 1. That is the highest score one model can have. But let's understand the effectiveness of the model now. For that, we are predicting a specific digit from a grayscale image. If we run this, we get the value as 9. Let's see the image first. The corresponding image is something like this. If you see this, our model has predicted that this is nothing but 9. But if you see visually, it is kind of 5. Let's see what is the actual value we have in the target variable corresponding to that same location. If you see, our understanding is correct. Actually, in this grayscale image, 5 has been written here. But our model, though the model accuracy is 1, that means 100% of the time our model will predict correct value. But that is not the case in reality. This is the problem if we provide the entire data set as training data. It will lead to overfitting. The accuracy of the model will not be very relevant for unknown or unseen data. Hence, this approach we will not be using during solving our enterprise machine learning problems. Let's take the better approach now. This time we are using train, test, split method of SKLearn in order to split the entire data set into training data and test data. As we have put test size as 0.3, that means 30% of the data will be reserved for test and remaining 70% of the data will be used for training the model. Let's run this. Now if you see, our accuracy is 0.981. That means 98% of the time our model will give you correct result. However, as we have discussed during our theory session, if we run the same statement multiple times, the model accuracy will change. This time it is 0.987. If we run one more time, it is 985. If we run one more time, it is 0.99. One more time, it is 0.99. Then what will be the correct accuracy of the model? Ideally, we should run this multiple times, note the accuracy for each and every iteration and take the average value out of it. Then only we can tell the average value is the effective accuracy of the model, because if we run this multiple times, different values will come as accuracy, which is misleading. Let's concentrate on KFold now. KFold is a very effective technique to fold the entire data into multiple folds and take one fold as test data and remaining folds as training data. This is effective when you have less data volume. We are importing KFold from SKLearn.model_selection and we are planning to split the entire data set into 10 different folds. Now, each time we will take one fold as test data and remaining folds as training data. And eventually, we will take each fold as test data in any one of the iterations. Hope you can remember the picture we have checked out during the theory session. If we run this, you can see it is running 10 times with different set of test data and training data. And each and every time it is evaluating the score of the model. In this way, these are the 10 different scores we have in 10 subsequent iterations. And finally, we are averaging it out to get more stable performance of the model, which is 97% in this case. Now, we can easily use KFold and write this much of code to iterate through all the folds and evaluate the effective performance of the model. But SKLearn library is giving you more ease to do exactly same thing with the help of Cross Val score. Cross Val score is also present within model_selection of SKLearn. It takes the model, the features and the dependent variable or the target variable and something called CV. CV15 means the entire data set will be folded into 15 different folds, and in each iteration it will take one fold as test data and remaining folds as training data and perform 15 different iterations to give us the scores. If you see here, there are 15 different scores logged here. What we can do? We can simply use mean method to evaluate the mean value of these 15 scores to get more stable performance metric for a machine learning model. This single line is performing exactly the same thing what we have written in this for loop, because even Cross Val score uses KFold internally. So SKLearn library is giving us this flexibility to use Cross Val score, which internally splits the entire data set into multiple folds. It performs multiple iterations to get multiple scores, and finally we can use mean method to evaluate the mean value of all the scores. Let's understand what is the takeaway from this session. In this session, we have not discussed about any specific machine learning model algorithm. However, in this session, we have discussed about KFold Cross Validation, which is used across all the machine learning and deep learning algorithms. It gives us flexibility to effectively use the observations or data samples and assess the performance of the model. We have discussed about the cons of no split case when we are not splitting the entire data set into test data and train data. During our coding session, we have realized what are the shortcomings of this approach and why we should not use this approach. We have seen how we can use train test split method of SKLearn in order to split the entire data set into training data and test data. But we realized as train test split is randomly splitting the entire data into train data and test data, every run will give us different score of the model. Hence, ideally, we should run the same instruction multiple times to get multiple scores and then finally evaluate the average of the scores to get more stable model accuracy. Instead of doing the same manually, we have option to use KFold. In case of KFold, we are folding the entire data set into multiple folds like this, and each time we are choosing one fold for test data and remaining folds for training data and evaluating the stable performance metrics of a machine learning model. However, There are some manual steps involved if we want to use KFold directly in our machine learning code. As a solution, SKLearn library has given us a more optimized function or method, which is cross val score. Using cross val score, we can perform the same thing what we are performing in KFold manually with the help of some iterations in a single line here. That's the benefit of cross val score method. These concepts are very important in the entire machine learning domain. Hope you have enjoyed this session. Thanks a lot for watching this video.